welcome back to some more geometry. Today we're talking about algebraic proofs. So algebraic proofs are just we're going to take the steps of what we do in algebra and just say, what are we doing? What is the concept we're going through? And we'll see what are different type of things. But we're going to do this in two-column proofs. So we're going to start working on two-column proofs. This is going to be our first time doing two-column proofs. Us, at least. You may have done it before, but this will be us. And we're going to do it with algebra, something we're kind of relatable with. So let's start about different. These are all called properties of equality. Equality means equals. Now, anytime you add, for example, here, anytime you add something, we call that addition property. You're adding. Anytime you subtract something, subtraction. Multiplication property, so on and so forth. Those are pretty simple, So, for example, if I already had two terms and I want to reduce them or multiply them by the same amount, in this case, look at C and C, that's called multiplication property. Pretty obvious. Anytime you want to divide by something, whether you divide reducing both sides by the same amount, it's division property. Now, reflection, symmetric property, these are technical things you say before you do some sort of multiplication, division, adding, or subtraction. Transitive property is where you say, hey, like as it says here, A equals B, B equals C, then the very first thing, A, is equal to the very last thing, C. We kind of did some version of that with the law of syllogism. Substitution, anytime you put one thing in for another one, and then distribution is when you actually go ahead and distribute something. So let's kind of take a simple math problem right here. So we're going to prove that if negative 5 times x plus 4 equals 70, then x equals 18. So the very first step is to write our original statement. What are we trying to prove? Our if statement. That's called our given. So we start with our given statement. All right, we wrote it. So from step 1 to step 2, what mathematical property happened? What did they do from here to make it look like this? Well, they distribute this 5 through and got this information. So what happened to go from here to here is distribution property. Distribution property. All right, and then from there, we went from here to here. So we went from having negative 5x minus 20 equals 70 to negative 5x equals 90. What happened here? Well, mathematically, they probably just added 20 to both sides. So they added 20 to both sides. So our step 3 is addition property. Yeah, addition property. In our last step, what they do from here to here, from step 3 to step 4, well, they divided both sides by negative 5. So if we divided both sides by negative 5, that's called division. Division property. Spelled that wrong. My bad. Property. So that's what proofs are. You're just labeling the steps of what's going on from the previous part to the next part. That's what we're doing. Now, other things that you might use here would be properties of congruency. The difference between, again, congruency and equality is congruency are you saying two things are the same. We don't know the length of DE or the value of angle D, but we know that angle D is congruent to itself. It's the same of itself, so that's reflective property. Symmetric property is, again, where you say, hey, if DE is congruent to FG, you can say backwards is still true. FG is congruent to DE. And transitive property is where you say, hey, somebody told me that angle D and angle E are the same, and also that angle E and angle F is the same. Well, if this is the same to that, and this one's the same to that, and these two are the same, then the very first thing, D, is congruent to the very last thing. Very simple as the transitive property of equality. So let's take this problem right here that has to deal with angles. We're talking about angles FGJ. FGJ. So talking about this, so we're given information. We're saying this angle right here is congruent, so it's the same as JGK. This angle right here. So these two angles are the same. We're saying those two angles are the same. All right. And then we're saying that JGK, this angle right here, which we talked about, is the same as congruent congruent as KGH, this angle right here. So let's think about this. I'm going to do this in green. So this and this are congruent, and this one and this one are congruent. So by transitive property, we can ultimately say that this first one's congruent to this last one. So let's say that. So we have our first statement right here. FGJ congruent to JGK, and JGK is congruent to KGH. So this is what we call our given. This is what we're trying to prove. This is what we start with. Ultimately, we're trying to prove this. So that's usually our last statement. We also, given information, we know that this angle FGJ they're using 6x plus 7 to represent that. So this is equal to this, and KGH is equal to that. So what happened, and we wrote it all right here. You can see it's all written right here. Now, right here, check this out. From here to here, the only thing that changed was they add this little m right here. That's just called property of equality. They're just switching it to equal. It's no longer congruent, it's equal. So you'll use this a couple times. But anytime we just switch things from congruent to equal, this property of equality. So because when things are congruent, it's just saying these parts, these two parts, they're the same, but we don't have anything malleable we can use. We don't have parts, individual parts, or numbers and letters that we can use to represent it. Now we can do that. So, all right. So for 1 and 2, it was just property equality. We switched things from congruent to equal, and then vice versa. If you're switching things from equal to congruent, that's property of congruency. So remember that. You'll run into that throughout the homework. Now, from 2 to 3, we went from FGJ equal to JGK, and then we said JGK equal to KGH. So what's gone? We got rid of this. We said that this first one is equal to this last one. That is our transitive property, as we saw earlier right here. Anytime that happens, where the first thing is ultimately equal to the last thing, that's our transitive property. So we'll say that it transferred equality. So transitive property. As you start to learn these, you can shorthand this. We can also write this as just, you can say trans property, and I will know exactly what you mean. But for now, I want you to kind of write it out so you're not confused. All right, now here's the kicker. We went from saying the measurement of angle FGJ is equal to the measurement of angle KGH to saying 6x plus 7 equals 8x minus 5. So what happened from here to there, y'all? Take a second, think about it. Yeah, we substituted. We replaced this, or we replaced this with this because we know they are equal. So that's called substitution. Substitution property, or just sub property. Yeah. Now this is then the algebra. It's just a simple algebra. From 4 to 5, what they do? They added 5 to both sides, so that's our addition property. 2D's. Ooh. I'm gonna erase that. It looks sloppy. A little more sloppy than normal. For some reason, this little pad I used to write this with is being difficult. All right, we just call addition property or add property. From 5 to 6, what do? We subtracted the 6x minus 6x to both sides. So 6x subtract property. And then from 6 to 7, we divided both sides by 2, or division property. All right, and that's it. That's all you're doing today. It's just kind of starting the concept of two-column proofs, but with algebra stuff right now. As we get into the chapters, we'll start then looking at more geometric concepts and using a lot of those geometric postulates and theorems that we have seen throughout all this. All right, y'all. Have a